All right, let's go because I want to talk a little bit more about the one theorem that's to be on there. There'll be a little bit more. All right, so let's talk about some theorems that'll be on there. First theorem: how to find the lengths of two intersecting chords. So if I go A, B, C, D, and E, how do you find the length of two intersecting chords? So for instance, and I'm not, this is just totally made up, 2x, x minus 6, 4. What's your approach now? How do you figure out the lengths of chords when they intersect? Let's go to the numbers. 19. How are we finding this one?
I think you multiply the AE and the EC.
I take the chord, multiply its segments that's created. AE times EC is equal to the other two segments created on the other chord, DE and EB. Good, good. So there's the product of two of the chords. All right, what if I go secants or tangents in secants? What do I got going on here now? How do I figure out secants? Or I could do a tangent in a secant instead. Same way. What are you thinking about here now? 14, 4. Oh no, not the angle, Greg. You're thinking about the outside angle, which I'll get to in a second. I'm talking about the lengths. Like if I put 2x, 4, 9, how are we doing this?
You add the two parts, two segments of each line together.
Whole
Times the part that's on the outside.
Times external. You got it. Whole times external equals whole times external. There you go. That's how I do two secants or a tangent. And remember, tangent, what do you know about the whole and external part of a tangent? Same thing. Same thing. What about two tangents? That's really the only thing I didn't cover right here. Two tangents. How do I find their lengths? 18, anything you know?
They're congruent.
Done. So they're congruent. Serena?
Will it be given quadratic formula?
You can use it on the reference sheet if you need to, because that goes into my next thing. There will be factoring. I'm telling you. Hi, everybody. There's factoring. I'm telling you, there's factoring on there. Whether you decide to factor or, like Serena just brought up, use quadratic formula, that's your call. Okay, that's your call. But there will be factoring, basic factoring that you guys have handled all year long. Any questions here? Still got more to go for the quiz tomorrow. Yep, Griff.
Other constructions.
I'm coming up. I got another slide here. Jonah?
So there's no factoring that involves the quadratic formula?
Let me put it this way. What I give you to factor, you should be able to factor on your own, but if you don't feel comfortable or you don't know what the numbers are that you need, you can resort back to quadratic formula. But yes, you should be able to factor it. Anything here before I move on? Okay, you got one proof on there tomorrow. All right, one proof. I'm not going to come out and tell you what it is, but we can go over your options. Really, you got two options tomorrow. Prove two triangles congruent. Or what else could I do to them? Prove them similar. Yep. What level course are you in, though? Yeah, you think I'm just going to do that and we're done for the day? Absolutely not. That might be a part of it. What else could I have you continue on doing after you know the triangles are congruent? Yeah, prove some of their parts are congruent by using CP/CTC. Yeah. Probably won't ask for the triangles to be similar, but it might be a part of it. What else could I ask after the triangles are similar? CSSTP, which would prove a proportion is equal, two ratios are equal. Again, I'm just making these sides up. And yeah, we are in honor. So maybe you'll prove the triangle similar to get the sides in the same ratio so you can finally prove what? Product of the means equals the product of the extremes. Yep. Anything's fair game. I should have probably went over what's the main way to prove the triangle similar that you'll be looking at. Angle, angle. Do we need to go over the 5 methods, or are we good of proving them congruent? We good? Now, is this a test? No. But to do this proof, you may, hey, don't be surprised if some earlier theorems come into play for that proof. Here you go. What's happening here? What's happening? Tammy?
Radius drawn to a tangent.
So, perpendicular. I may need to know that to get a right angle in my proof tomorrow. What's happening? Sorry, I should probably put that. What's happening here? Paul? May need it in the proof tomorrow. So just because I'm not calling this a test doesn't mean you may need stuff from quiz 1 and quiz 2, especially the theorems. All right, especially the theorems. Griff, going to your question, yes, there will be 1 construction, and you guys know it's going to be 1 of 4, right? What are the 4 possibilities tomorrow? We just did them yesterday, right? Tammy? Hexagon. Jonah?
Equilateral triangle.
Which is the same construction as the hexagon, isn't it? So I say 4, but there's really 3 to know how to do. What else could I ask you to construct? Hexagon, equilateral, square. And then finally, I could ask you not to do any figure, but just draw a line that is tangent to the circle. Tangent line, yep. And I know we just went over it for homework, but circle equation will be on there. And yet, look, let's not joke around here. It's going to be completing the square. I'm going to give it to you in standard form, and you have to complete the square to get it into circle radius form. So you can tell me what the center and the radius is. All right, so there you go. Expect it. Standard form, get it into circle radius by using completing the square. And I went over a bunch of theorems that may come into play in the proof you have to do tomorrow. The other one I didn't put on there because it's already written down at the top of your page. If 2 chords are parallel, parallel chords imply congruent arcs. Okay, remember that. Parallel chords imply congruent arcs. Anything you want to go over? Oh, shoot. 1 more. Sorry. Anybody know what I'm missing? I've been advertising it since quiz 2. Charlotte? What's up? Yep. King size circle problems. 1. Just like the 2 that were on your quiz. All right, I put 2 on quiz 2. That's exactly what you can expect tomorrow. I do not have any in the review that you probably haven't done, but where are there extra? Google Classroom, 64 extra problems if you want to get practice at your king size ones to refresh your memory. So yes, this is about as close as I can come to a test without being as long a 2-day ordeal. There's only 8 questions, 28 points. All right. If anybody's wondering, 4 out of those 8 are multiple choice. Anything else? Anything you want to ask me? Make sure you add to today's packet work, add in number 31, because that's a proof that you should be able to do. In fact, 29 through 30 are proofs. I don't know if anybody tried 30 before quiz 2, but 29 through 31 are your proofs. King size circle problems are on Google Classroom. Any issues? All right, if there are issues, call me over. Let me know what you got. You know the deal. You can work with other people, but I'm really not in, especially after the performance out of a lot of you on Circle 2, not in the right frame of mind just to hear drama from other classes or outside of school. So work with whoever you'd like, but pick your poison wisely.
I did,
Yep. All right, Paul. Thank you.